Hey everybody, it's good to see you back again. So what are we doing today? Well, you just watched a very brief excerpt of the work I've been doing over the last 3 to 4 days to reconfigure the track press setup to press link halves back on. I had purpose built it initially just to press link halves off. So I had to change a few different things to, well, make it perform a slightly different task. I'll show you what I'm talking about. The first thing I decided I needed to do was move this backstop forward, and I had drilled all these holes on 4-inch centers kind of for that purpose. And being that everything has been pressing back together with a lot less tonnage than it required to press apart, well, I decided I could afford to lose these back series of bolts, and we're still going to be plenty strong right there. So we just moved that ahead 4 inches, and these pieces right here, we'll get this out of the way. You just saw me set up here. They used to be laying on their sides like this between the cradle and the backstop, and you can see partial bolt hole sticking out right there. Well, I found that if I could just set them up like that behind the cradle, that's going to give me the perfect amount of space right there for supporting the back sides of the pins and bushings that are already in the first link half sets. The cradle, of course, is bolted in place. There's a bolt on each side, so that's held stationary. And in this application, we're not going to be applying any force up against it, so we're not going to need that top brace. All it's doing here is just holding the links in alignment with the main push plate right there. So I changed out my pin pushing adapters for a set of link pushing adapters that I just made on the lathe. These are that same A2 tool steel that I made my prior bushing receiving die out of. I have not flame hardened these, and these are harder than, you know, regular mild steel. I'm going to try a few links with these and just see how they hold up. I'm thinking I may have to flame harden at least the face of this one because, well, I'll put that back in place. We'll set a couple of link pieces in here and I'll show you why. First thing we need to do is take this other round adapter that I had not yet talked about. That's made to go in the end of the bushing, like so. And with the links placed in the cradle, you can see how that adapter presses up against this block back here. The end of the track pin that sticks out just proud of the link boss on this end is up against the other block over here. So the cradle is just providing the alignment, and this adapter, these blocks, and the backstop are fully supporting the bushing and the pin. This inside link that's already positioned is just floating. Nothing can move it at this point. And from this angle, we can see how the other two push adapters are supposed to work. I cut a rather deep pocket into that one. That is to give the bushing a place to go, as the flat face of it that surrounds it is actually going to be pressing upon the tail end of the link. We also cut a rather shallow pocket in the face of the other one, so we have the flat face is going to be pressing on the end of the link boss up at the front up here, and then that shallower pocket just gives the end of that pin somewhere to countersink into. Let me see if I can actually, yep, here we go. Doing this with one hand is kind of fun. Just like that. You can see the bushing actually went inside and the link actually settled into that pocket on the other end. Now I'll just place the other link half in here. They start rather well and hold themselves in position onto the end of the pin and the bushing. And you can see where, yeah, this adapter is going to be pressing on that area outside of the bushing bore. And then this other one, like I said, is just going to be pressing on the end of that pin boss at the front. It's going to depend on how well that pin in there wants to start into that pocket on this one. That's going to dictate whether or not I end up flame hardening at least the end of that, because if the pin wants to come in and keep gouging the edge off of that pocket, I'm probably going to have to do something about that. So that covers the mods that I had to do to the actual press frame itself. That, however, was not the end of the tool making. I'll show you the other things that I had to figure out as well. You all should remember from last time, I had to be sure to install one special shorter master bushing in one link from each set of tracks, because that's only half of what it takes to split a track. Here's the other half. you need to have 2 links that are pressed onto a standard length bushing, because the master pin goes through those. You don't worry about a pin in that instance. And that is because, well, you need that shorter master bushing to allow those 2 link halves to be easily taken apart and put back together. All right, if you used a standard length longer bushing that sticks out on each side, that's not going to go together. So instead of the master bushing countersinking into both of those inner link bores, you just fill those with spacers, and that special shorter one just takes up the rest of the gap in between. That creates another problem though. How do you press 2 link halves onto one bushing and keep both of those pin bores in perfect alignment? All right, with the rest of these, you have the convenience of the link centering itself because it starts on the pin and the bushing at the same time. You don't have that with this, and if you get these 2 links out of alignment, you're not going to be able to get a master pin in there, and then the surface that the trackpad bolts to is going to be uneven, and it's going to want to rock on the pad besides. My solution was to make a dummy pin. Instead of being a tight press fit, this is just a slip fit. If you line it just so, it will, and it has to be, there we go, it has to be right. It's a pretty close fit, but it will allow those link halves to drift up and down it. So that is how I was able to keep this end of the link halves in alignment. They both self-centered one another onto the bushing at the other end, and with this dummy pin in place, I just used a similar pressing setup as I did when I did the initial turning of the bushing and pressing it into the first link half. Pressed them both together, and as long as I still had a good slip fit between bores on this end, I knew they had to be lined up. That still does not bring us to the end of our problems though. There's always one more. The final thing I needed to address was how to get that second link half pressed on to proper depth. What I mean by that is if I pressed the link halves on the pins and bushings too close together, or if I did not press them on far enough and they were too far apart, none of the trackpad bolts would line up with any of the holes. This is the alignment I'm talking about, how to make sure the spacing between these 4 holes is going to perfectly match the spacing between those 4 holes, because there is not a lot of wiggle room. These bolts are made to be a pretty tight fit in all those holes. They have to be if they're going to stay tight over the long term. With these first 2 link halves, I just kind of eyeballed everything, and it all came in to where I could start all 4 of the bolts, no problems. But just doing the eyeball method is very time consuming and highly prone to error. So I decided to make a go/no-go gauge. The concept is extremely simple. You just get 4 studs that are arranged on that bolt pattern, and you make it just very easy to manipulate so that you can come over to the press, and as you're pressing the link halves on, just keep checking it. When the 4 studs line up with the 4 holes in your links, you're good to go. The easiest way I found to do that was I cut apart this old street pad. I had a whole set of these D2 flat, some people call them street pads, some people call them turtle pads. They were off of an old D2 track-excavator, basically a front-end bucket cat that had these flat pads with no grousers. They were worn out and shot, but this provided the perfect template for mounting 4 studs that's going to match that bolt pattern perfectly. All these track pads went onto the same links. So removed the excess material that I didn't need, turned the heads off of 4 7/16 diameter bolts, just left the straight shanks out, just beveled the edges a little bit to help them guide in, and we verified our work against the other track pad. Yep, all 4 line up just so we know everything's level and plumb and spaced properly. So as I'm pressing links together over here, this fits in here. I can just keep checking it against the links that are in the press, and once the studs line in with the holes in the links, you know everything is good to go. So that was the final tool that I had to make for this process. So although we're not going to actually press any links today, I wanted to make this episode just to illustrate how much, work, how much time goes into putting together, what, a 12, 15, 20-minute episode, much like this one, I'll have 4 days just in prep work, behind the scenes stuff, getting everything thought out, fabricated. I'll start off, with a certain approach, halfway through decide that it's probably not going to work, abandon it, take it a different direction. You do that 2-3 times. Pretty soon, it doesn't take very long. You're days into it and you still don't have a single episode made. And this track work, I can say, has been the largest undertaking of the rebuild of this entire D2. I mean, all of this stuff that I'm using here, I had to make, okay, except for this cylinder. I did buy that. But the rest of the stuff didn't exist before I started working on track chains. And it wasn't until I got this press in the building I realized it's fully half the size of the tractor. So a lot goes into this, and just the tedious, the repetitious, all the same steps for every one of those links, both sides, the other set over here. Yeah, it's a lot. So I thought this was worthy of an episode by itself, but a lot of good questions have been popping up in the comment section. Some of them have been addressed before. A very common one was, what is the setup the Caterpillar used in the factory back when they were building all this stuff new? I don't rightly know. I've never seen an illustration of it. I've never heard of it being described. I'm sure it was a huge, big industrial, extremely efficient process, huge machines, large pressing capabilities, precision tooling. They would have to have been doing this stuff very efficiently to be cranking out sets of track chains for every model of tractor that was coming off the line every day. I've also talked about the 6F25 portable service press. It's in a bunch of episodes on the channel here. Check out, well, I'll pop a link to a playlist. That's the chassis playlist for the 5J1113 rebuild. I've illustrated that in other episodes before, but other people were saying they didn't realize that pin and bushing turning was such a big thing, and in fact it was. So again, we're going to go to the selected articles from Service Magazine's book. Required reading for anyone that has an interest in vintage Caterpillars. Pin and bushing turning, replacement, and just general track work was a big thing with Caterpillar Tractor Company. And I want to show you this article right here called Track Repair Arrangement. You can see we've got a guy in a pit, track press is in there with him, and it's set at floor level, so the conveyor just takes the chain straight across the floor. And it says, shown here is a photograph of the recently completed track repair facilities of the Sierra Tractor and Equipment Company Caterpillar distributor at Chico, California. As can be seen, the arrangement is unique in that the press is set in a pit approximately 12 feet by 12 feet by 3 feet deep, and the track conveyor is set flush with the floor. The distributor service manager states that this arrangement not only makes the job of handling heavy track assemblies easier and safer, but has also made possible a reduction of 1.5 to 2 hours in time required to remove and install pins and bushings in a D8 track assembly. This idea merits study when considering the installation of a track pin press. So, dealers were definitely getting word of better, easier, safer ways of doing things. Another article in here, a dealer made a track wind-up machine when doing this type of work out of the Scarifier lift gearbox assembly from a Cat 12 grader, and then they actually showed illustrations of it, powered it with an electric motor. There's a Scarifier lift. They turn the arms into different pegs for grabbing onto the track links, and you just plug the motor in and it would just slowly wind the track up, so you didn't have to do it by hand. They even made a height adjustable stand for it that folds up. I mean, they did so much track work like this back in the day. Everybody was just trying to come up with better ideas, better and safer ways of doing it. Another common question that came up was, wow, the labor you're investing in this, how could it be worth doing it today? Well, they are still doing pin and bushing turns to this day, just with a couple quick YouTube searches. I found videos of a guy doing, I believe, a Cat D11 track chain, and he was applying in excess of 100 tons to the pins and bushings, pressing them out, pressing them back together again, and the noises, the creaking, the popping that metal was making under pressure was downright spooky. I'm glad I didn't even have to be in that room. But it's not done as much today as it used to be. Labor costs a lot more now than it used to. And, well, they've streamlined their manufacturing processes to the point where most of the smaller track machines now, it's actually cheaper just to run the tracks out and buy new. Don't try and replace anything. But the larger ones, D10, D11, there can still be cost savings in investing in a pin and bushing turn to get the most life out of your tracks. Another common question was, instead of pressing all this stuff together under, the tonnages that you are, would it not be better to use the heating and expansion and then freezing and shrinking method? So you would heat the links to expand them, you would freeze the pins and bushings to shrink them, and then everything goes back together better. And then once temperatures equalize, you've regained your press fit. If you're dealing with all brand new components, I could say maybe yes. With this used stuff, I personally like to have the feedback of how tight is this stuff? How much force is it taking to fit them back together? Just like using that hand pump over the electric pump on the cylinder, I like that, that positive feedback of it. And to illustrate why I don't personally utilize any of the heating or shrinking methods, on anything, I just don't do it, I'll show you on the bench. So I saved this link out from when I was doing the initial pin and bushing turn and pressing them each into the first link half. You can see the white paint I put around that pin boss. That was to indicate that this bore was actually oversized. We did not have a good press fit in this link anymore. Possibly it had too many pins pressed in and out of it, over the years. I don't know. Something could have happened. Maybe the metallurgy was just a little bit off and it stretched. I'm not sure, but well, you can see how I can hand start that pin like 1/8 of an inch into that bore, and that should not be possible. That's such a tight press fit. You should have to actively press that with tools the entire way. And the only reason I flagged it was I noticed the pressure gauge on the electric pump was barely reading 2 tons by the time I had the pin all the way in, and it should have been 8 tons plus the whole way to push that in. So I took it back apart again. Didn't take much at all to press that pin out. Sure enough, trying different pins in that link, I had the same result. Verified that we had a bore that opened up way too far. So I marked it, we set it aside. This link is scrapped now because there's no way you're gonna get a standard pin or a master pin to ever stay tight in that. If you would have, used the heat up and shrink down method and just click those together, there's a very good chance that would have gotten right past me. And then you put that in service, that pin is gonna start loosening up and moving. So that's why I just prefer to press everything together at ambient temperature. You know exactly what all your fits are. So that's going to do it for this episode. We are tooled up and ready to start assembling track. We've got the initial starter links made for each side. So with those already put together, we just start clicking pins and bushings, pressing that second link half on, and you repeat all the way through, assuming it all works. We're about to put it into practice. So tune in next time for that. As always, everybody, thanks for watching. Time to get busy once again.